Okay, this question is I will say it's a little bit tricky because it involves integration. It also involves the rate of change. And there's a lot of things being linked together. If you couldn't piece up the information, you'll find this question very confusing. Okay, so first of all, you got the rate of change of radius. So this is the rate of change of radius. And where does the radius come from? It comes from a circular patch of water. So some students might even miss this out. So it's a circular patch of water with this radius. Okay, and then they actually gave you two information. They gave you the initial radius. So initial radius means t equal to 0. The radius is 1. That means it already starts with a circle with radius 1. Then after that, it slowly expand out. Okay, and then it also tells you that when t is equal to 0, initial part, the rate of change of radius is 0.5. Meaning the 0.5 means every 1 second, the radius is increasing by 0.5 centimeter. So that is the interpretation of the rate of change. Okay, so first part, you need to show k equal to 0.5. So you can look, so which information will help you to solve for k? Which information will help you to solve for k? So essentially, it should be this second piece of information. So if you put the 0.5 here and put the t equal to 0 here, you will actually get the k equal to 0.5. So when the k equals 0.5 is found, whether you find it or not, actually you can just return it. So your dy dr dt is actually complete. So with the completed dr dt, so some students will get stuck on this because they may not understand what exactly it is. That means you need the radius in terms of t. So it actually comes from the backwards. So that means you actually got to integrate back. If you integrate back, you actually get this because you have a dr dt. So in order to get r in terms of t, you need to be integrating. So this part is the one that some students may not relate. You didn't think of integrating. So once you think of integrating, it's just applying the formula. So I am applying the formula of 1 over ax plus b equal to 1 over a ln ax plus b. So if I apply the integration, there will be a plus c. And that's why you are given this to find the c value. You are given this to find the constant so that you got a proper formula. So this is the formula for radius with time. Okay, so don't forget what you have found here. And don't forget what the information here, because you're going to turn over the page with all this information. Okay, and then when you turn over the page, you'll find that suddenly there's a rate of increase of the area. So this rate of increase of area is dA dt. And the patch has been expanding for 3 seconds. So you already got the formula of the radius with respect to time. So you can get the radius first. It's easier if you get the radius. Just plug inside. So you get the radius. You can have it with a lot of decimal places. So your job is to find this. So eventually, I'm going to be using my rate of change formula. So eventually, I'll be using my rate of change formula. So this is in the previous part. Now you only need to get a dA dr. dA dr must come from the circular patch. So you must realize that you are dealing with a circle. You are dealing with a circle with radius r. So that's why you must come out with this in order to get your dA dr. Then you can just apply the formula So apply this formula properly. And then you get the proper DADT. So after the proper DADT, you can just insert the whole radius inside and then just punch out. That's all. So there's a lot of formulas, there's a lot of information. So sometimes when you flip the page, right, you forgot what you have in the front. So always flip back and see. Okay, so it's actually not so difficult if let's say you can see all the information that's presented to you.